Everyone, welcome back to my channel. Today we will discuss about V number and mode theory in fiber optic communication. So you all are aware that in optical fibers, the light travels from source end to the detector end because of total internal reflection. And for the total internal reflection, our angle of incidence must be greater than that of critical angle, or our light must fall in acceptance cone. And because of that, then it travels because of total internal reflection. So it consists of core whose refractive index is more than that of cladding's refractive index. So core is covered by cladding, and that cladding is again covered by jacket to protect the optical fiber. So protect the propagation of light depends on two fiber parameters, two important parameters. The one is V number. It is number, so it decides how many modes can travel through the fiber. You all are aware that there are two types of fibers, single mode fibers and multi mode fibers. I have prepared separate video for that, and the link is given in the description box. So it decides how many modes or how many guided light wavelengths can travel through the optical fiber cable, and another one is beta or propagation constant. So let's discuss about these two important parameters, V number and propagation constant. So first we'll discuss about propagation constant beta. So see here, to propagate light through optical fiber, the condition is the beta, that is propagation constant, must be less than beta 1 and it must be greater than that of beta 2. It means the propagation constant must be greater than that of propagation constant of cladding. Beta 2 stands for 2 pi by lambda. Here lambda is a wavelength into N2. N2 is refractive index of cladding. So propagation constant must be greater than that of cladding's propagation constant, and it must be less than that of core's propagation constant. You need to remember the condition. There is coarse propagation constant. We can call it as N1K. In few books, it must be given as N1 into K. Here K is 2 pi by lambda. So our propagation constant must be between these two values. If propagation constant is less than that of beta 2, that is cladding's propagation constant, then instead of light ray travels through core material, it travels through cladding or it refracts into cladding. So see, there are two types of modes, guided modes and leaky modes. Guided mode means the mode which travels through core and which can travel up to receiver. But leaky modes means they leaks into cladding. They don't reach to the receiver end. And why leaky modes occurs? If propagation constant is less than that of cladding's propagation constant, then obviously light will enter into cladding because the propagation constant is even less than cladding's propagation constant. So leaky modes are modes that are not fully confined within the core. They gradually lose power due to partial penetration into the cladding. Now let's discuss about V number. So you know now condition for propagation constant. Its value must be between propagation constant of core and propagation constant of cladding. Then V numbers tells us how many modes can travel. First parameter beta tells us whether light can travel or not. To travel light, its value must be between beta 1 and beta 2. Second parameter tells us how many modes can travel. So, formula for V number is 2 pi a divided by lambda into n1 square minus n2 square. This is in under root value. So, it is 2 pi. A is radius of our core radius. And here lambda is wavelength, n1 is refractive index of core, n2 is refractive index of cladding. So here by putting value of radius of optical cable, the wavelength and value of numerical aperture, see in exam questions can be asked on calculate V number, calculate how many number of modes can travel through optical fiber. So parameters must be given, like radius must be given, wavelength is given, numerical aperture is given, or if numerical aperture is not directly given, then value of n1 and n2 must be given, or the delta must be given. So see, if that V number after calculation, if your V number is less than 2.405, then remember this is single mode fiber. Only one mode can travel. So for multi-mode operation to travel multiple modes through optical fiber cable, a V must be greater than that of 2.405. And to calculate number of modes, the formula is m is equals to v square divided by 2. Here v stands for number of modes. So if v is less than 2.405, one mode. And if v is greater than 2.405, multi-mode fiber, and number of modes you can calculate by putting value of v here. So in this video, we discussed about mode theory of optical fiber, how many modes can travel through optical fiber, what is V number of optical fiber, and what is the propagation constant which is important for ray to travel from source end to the destination end. So if you found this video useful, please like, share and subscribe to my channel. Thank you so much for watching.